Alright. The name of our lesson is Proof Formats, the two-column proof, the figure. Our goal is to identify the appropriate figure for a proof. Okay, we've been talking about proof formats, the two-column proof. So the next part we're going to talk about in the proof format, in the two-column proof, is the figure. So go ahead and skip a space. Let's go ahead and write today's date. And today we're going to talk about the figure. Okay. To prove a statement in geometry means to demonstrate that the statement follows logically from other accepted statements. The format of a two-column proof consists of 6 essential parts. We talked about the statement of the theorem last time. So now we're going to talk about the figure. Each proof should have a lettered figure drawn to illustrate the given conditions, the hypothesis of the statement. Although a diagram is not essential to the logical reasoning of the proof, it helps to see the deductions being made. You may be able to make some inductive conclusions and then justify them deductively. Be sure your figure accurately depicts the given conditions. Do not add any special features that are not given. Do not draw a right triangle or an isosceles triangle when a triangle is specified. Make the figure as general as possible. A common mistake that students make when doing a proof is drawing an assumption from the figure when it is not actually given in the original information. Unless your information gives you specific information, you should always draw the most general case. For example, do not assume that 2 line segments are equal unless you are told they are. Do not assume an angle is a right angle just because it looks like it. Unless the given information tells you, you cannot assume anything. Okay. Model 1. The sum of the measures of the angle of a triangle is 180 degrees. So this is what it says. So we said the figure okay, and we want to draw a general sketch avoid adding any information that isn't specified. Okay. For example, let's say that this is what I'm given. The sum of the measures of the angle of a triangle is 180 degrees. Okay. The sum of the measures of the angle of a triangle is 180 degrees. The sum of the measures of a triangle is 180 degrees. Okay. Now it says a triangle. So draw and label a triangle, not a specific one, because a special triangle was not specified in the given theorem. So we don't know what kind of triangle it is. So we're just going to draw just a triangle. Okay, we're just going to label it A, B, C. Okay, that's all it told us. So that's all we can do. Okay. I don't want to draw a right triangle because then we look at the picture and we think, okay, it's a right triangle, when the directions didn't say that. Okay, so try not to add any information besides what it says. Okay? Let's try another one. Let's say it says, if two parallel lines are cut by a third line, the alternate interior angles, I can't talk, are equal. If two parallel lines are cut by a third line, the alternate interior angles are equal. Okay, so let's draw a diagram. Okay, we have parallel lines. Remember, parallel means they'll never ever touch. So here we go. Here's a parallel line. Here's a line parallel to it. Okay, there's two lines. And it says if they're cut by a third line, there we go. Okay, so we have angle 1, angle 2. Okay, those are alternate interior angles. We're saying that these two angles are equal. That's all we know. Okay? We can name the lines. That's fine. They named them L and M, just so it's easier to, if we give them a name, it's easier, we know what to call them when we're doing the proof. Okay? Oh, I didn't name this line, so this is line T. Okay? So all we did is we drew a picture saying exactly what it said. We named the lines, but that's all that we did. And we named the angles. If two parallel lines, we drew two parallel lines, are cut by a third line, we drew the third line. The alternate interior angles are equal. So we put the angles there. We named the lines. That's all we can do. Okay? Okay, let's do another one. What if it says, through a point outside a line, exactly one line can be drawn perpendicular to the given line. Okay, through a point outside a line, exactly one line can be drawn perpendicular to the given line. Okay, so let's draw a picture. So we have a line that says we have a line. Here's a line. Here's a point that's outside the line. It says only one line, exactly one line can be drawn perpendicular to the line. So here's my diagram. Perpendicular means an intersection. Okay? Alright. So today we talked about drawing a figure to represent the if-then statement that we talked about last time. We talked about, remember, you only use the information given. You don't add any information to the drawing that's not given. Make your drawings as general as possible. Okay? Alright, so let's do some of these. Number 1. Through a point outside a line, one line can be drawn parallel to the line. So through a line, number 1. Through a line outside the line, outside a line, one line can be drawn parallel. Can be drawn parallel to the line. Okay, I want you to stop the tape, draw a figure for this, and then compare it with mine. Okay, let's see how we did. Through a line, outside a line, one line can be drawn parallel to the line. Oh, this is supposed to be a point. That's why that doesn't make sense. Let's do this again. Through a point. Okay. Now go ahead and try it. Okay, so let's try it. We have a line. Should have drawn a line. Should have drawn a point out here somewhere. It says you can only draw one line through this point to make it parallel to this line. So here we go. Okay, so yours should look something like mine. Okay, now I want you to go ahead and study your notes, review this lesson, and go ahead and answer the questions.